So good morning. Today we are going to discuss about folds part 2. In folds part 1, we have studied the various origins of the fold as well as the morphology of the fold, where we have seen that how tectonism or the compressional stress is responsible for the fold formation. At the same time, we have studied the morphology of the fold, in which we have seen the axial plane, the hinge point, hinge line, the limbs of the fold, and so on. And we have also seen some of the field examples of the fold. In this session, we are going to discuss about the classifications of the fold, which is a very extensive topic. Let us discuss about the classification. Basically, classification of the fold has been done on the basis of 6 heads. The first is orientation of axial plane. As I have already told you, the plane which divides the fold into two halves is considered as axial plane. Then it can be classified on the basis of plunge. As we have already discussed in previous lectures we have done, that plunge is the angle between the fold axis with respect to the horizontal surface. Then on the basis of interleave angle, means the angle between the two limbs. Then a well-known classification given by Ramsey. Then on the basis of the profile of the fold, and finally on the basis of mode of the occurrences. So let us discuss the first on the basis of orientation of axial plane. So on the basis of the orientation of axial plane, you can get these 5 kinds of folds. Let us discuss them. The first is the upright fold. When the axial plane is exactly vertical, in that case, you can term that fold as an upright fold. Okay. Sometimes it is also called as a symmetric fold. Why? Because if your axial plane is exactly vertical, then that fold can be divided into 2 equal halves. And hence, it is also called as symmetrical fold because on its division, it is divided into exactly 2 equal halves. And if the axial plane is slightly inclined, in that case, you can call it as an inclined fold. And again, the another name is asymmetric fold. Okay, so you have 2 types. If the axial plane is exactly vertical, then it will be a upright fold or a symmetric fold. And if it is slightly inclined, then in that case, we will call it as an inclined fold or an asymmetric fold. Because on division or on dividing that fold along the axial plane, you may not get the symmetric halves. And in that case, you call it as an asymmetric fold. Then consider that the axial plane is more inclined. Okay, it is inclined for more degree. In that case, you will call it as an overturned fold. In the right corner, you can see that there is an overturned fold where the axial plane is highly inclined. And if the axial plane becomes exactly horizontal, in that case, you can call it as a recumbent fold. So on the basis of axial plane, we have divided them in, basically they are in 4 types, but the 5th type is also there, reclined fold, where the axis is completely inverted. So basically it was an anticline, but due to inversion, it looks like an syncline. So an upright fold, recumbent fold, inclined fold, reinclined fold, and overturned fold are the well-known examples of the orientation of axial plane. Let us see another head, plunge. So as we have already discussed about the plunge is the angle made by the fold axis with respect to the horizontal surface. So if your plunge is 0, in that case, you will call that fold as an horizontal fold. And if there is an angle between the horizontal plane with respect to the axial line or axial plane, in that case, you will call it as a plunging fold. And if it is exactly vertical, then we'll call it as a vertical fold. But basically, you can divide it into 2 halves. The first is plunging fold and another is non-plunging fold. Means the fold which has a plunge with the horizontal surface, you will call it as a plunging fold. and the fold which is not showing any kind of plunge, in that case you will call it as a non-plunging fold. Interleave angle. So this classification is done on the basis of the interleave angle. Okay, the angle depending upon the angle between the two limbs of the fold. So let us see how they are classified. So when your angle between the two limbs is 180 degree to 120 degree, in that case you can call that fold as a gentle fold. And if the angle goes to 120 degree to 70 degree, then it can be called as an open fold. And if on further compression, because you know that the gentle fold is formed when the compressional stress is slightly weak. But as the compressional stress will increase, it will tighten itself. So after the open fold, you can see the closed fold, where the angle between the two limbs is 70 to 30 degree. Again, if the compression increases, then you can get the tight fold, where you will get the 30 degree to up to 5 degree or below 5 degree angle will be the tight fold. And sometimes on further compression, it develops into closed fold or even isoclinal fold. Isoclinal means where the two limbs are exactly parallel to each other. So the compressional stress is responsible for such type of classification, because if the compressional stress increases, the fold gets more and more compacted. So ultimately resulting into such kind of classification. Let us see the Ramsey classification. This is the well-known classification given by Ramsey. Here you have basically three types, that is class 1, class 2, and class 3. So actually it depends upon the curvature of inner liner and outer line. Okay. So basically when there is a fold, you can see that the outer exterior has a different deep and the interior has a different deep. If the interior angle or if the interior margin is having more higher curvature, in that case, it can be called as a class 1D, because the interior of that fold is having a higher curvature. And if the exterior of the, for example, if the exterior of the angle is having higher curvature, in that case, you will call it as a class 3. And if both the margins have same curvature, in that case, you will call it as a class 2 fold. So you can see here the class 1A, class 1B, and class 1C are for the classifications. But the fundamental concept is same, that the inner curvature should be higher than the outer curvature. Then it will be a class 1. The outer curvature, if it is higher, then it will be called as a class 3. And if both the curvatures are same, in that case, it will be called as class 2. It was given by Ramsey. Then let us see about the profile of the folds. Profile means if you cut the fold, okay, and the profile you get after the cutting, on that basis you classify them accordingly. It is some kind of miscellaneous classification. But the well-known examples you can see here, the Chevron fold, CHEVRON Chevron fold, where you can see the profile is very acute, isn't it? You can see that the profile or the curvature is very acute. It is not like that, it is very acute. And because of that acuteness, these are named as Chevron fold, or sometimes it is called as zigzag fold. The other well-known example on the basis of profile is the box fold. Means when you cut the fold, you will get a box type of profile. So this box type of profile or box type of fold has two axial planes, okay? Because you can see here there are two curvatures. A flattened portion is there, and at the end there is two curvature. There are two curvatures. So ultimately they develops into two axial planes over there. Then we have on the basis of mode of occurrences. So the mode of occurrences, the well-known examples are anticlinorium and synclinorium. Here, the anticlinorium, you can see that if it is an anticline and if it is further folded into second and third generation, in that case, it is called as anticlinorium. And whereas if the folds are, if the oral fold is a syncline like this, and if there is a multi-folding in it or a next generation folding, in that case, it can be called as a synclinorium. Usually the mountains or tectonic mountains shows anticlinorium fold, whereas the basins, big basins, tectonic basins indicates synclinorium. So let us see some of the well-known pictures on the basis of which you can identify the various folds in the field. You can see that in the first picture, you can see there is a syncline and anticline, a set of syncline and anticline. Okay, it is very beautifully explained by the animation. So you can see that how the syncline moves over there and it converts into an anticline, and there is an axial plane. Okay, see the animated axial plane over there, and the hinge zone where the hinge point is there means the point of maximum curvature, isn't it? So you can easily trace out, or you can easily understand the folds in the field with respect to such kind of animated versions. Let us see the next picture where you can see the plunging fold. See how beautifully has been converted into, with the help of animation, it is converted into more, explainable picture where you can see the plunge angle with it, isn't it? See, there is a hinge line. Okay, hinge line means the line joining the point of highest curvature. That line is having an angle with the horizontal surface. That angle is called as a plunge angle, and this is a plunging fold. In the corner of that picture, you can see the animated version. Okay, in this case, you can see how the horizontal plane is there and the fold is inclined to it. So these are the very beautiful and quite expressive pictures of the folds in the field. So let us have a revision what we have studied today. So today's session was on fold part 2. The fold part 1 was on the definition, morphology of the fold, and the fold part 2 is about the classification of the fold. Okay, so in this classification we have seen the classification on the basis of orientation of axial plane, plunge, interleave angle, Ramsey classification, profile, mode of occurrences, where we have seen the orientation of axial plane. Okay, how the plane, how the the folds are classified on the basis of axial planes, that is upright fold or symmetric fold, inclined fold or asymmetric fold, and the overturned fold, reclined fold, recumbent fold. Okay, then we have seen on the basis of plunge, if it shows plunge, it is a plunging fold. If it is not, it is called as non-plunging fold. It can be further referred as horizontal fold, plunging fold, vertical fold. Then we have seen the interleave angle, where we have seen the folds are classified on the basis of interleave angles. If the angle is 1 into 120, it is called a gentle. If it is more compressed, then open, then close, then tight, and ultimately you can get an isoclinal fold. Then we have seen the Ramsey classification, a well-known example of Ramsey classification, where the class 1, class 2, and class 3 is given. It depends on the curvature of the inner and outer margin. Okay, so if the margin is acute in the inner side, it is class 1. If it is acute on the outer side, it is class 3. And both the margins have same curvature, in that case, you will call it as a class 2. Profile, okay, there is a chevron and box folds are well-known examples on the basis of profile. Then we have seen on the mode of occurrences, where we have seen anticlinorium and synclinorium. And some other examples are also there, like similar fold, asymmetric, non-similar fold, etc., etc. There are miscellaneous classification, but the discussion was done on the major type of classifications. And then we have seen a beautiful animated example in the field. Okay, so where you can see that how with the help of animation, the folds in the field are explained. Okay, so this was all about the classification of the fold. Thank you very much for your patience listening. Thank you.